Hello everyone, good evening. So this project is part of uh, Age and Force Computing course. So my name is Arpit Kulshrestha, and this paper is about HealthFog, the diagnosis of heart disease in integrated IoT and fog computing environment. So let's move forward with this. So, what was the problem this paper is solving? So, basically, there's nowadays IoT basic infrastructure is there and things are there, but what's the problem? The real time communication and real time sensing and alerting the system, specifically in the case of diseases. Let's suppose there's some heart patient data which needs to be really computed at the age nodes, and that needs to be triggered the alarm of maybe doctors and family members and hospitals, and that we want to monitor a patient specifically, then that's really needed. Maybe at the time of night, there's a need of such kind of system. Then this paper is solving, combining multiple things like IoT, mobile app, architecture, cloud, agent for computing, and we will see how that architecture work. But that's this paper is all combining all these things, and this IoT competition is happening in this way. So it's just combining a lot of things under the hood and solving a problem, which is like if there's a patient which have problems related to heart disease, and we really want to monitor the situation at real time basis. So as soon as that panic attack and things happen and data has changes, then that computation needs to be handled, computation need to happen, and that need to trigger the cloud and AWS IT cloud, and that need to be informed to people, whoever needs to be informed that information. So then this paper is trying to solve this problem. Let's talk about this problem versus a health problem. So actually, this problem is specifically in this paper is talk about heart, but that can be implicated in other things, other real-time diseases like other which is critical diseases that on the basis of data and computation we can also manage to inform that infrastructure that okay, there's some issue at the end of a patient. Maybe in that patient is in under the home surveillance or maybe under the hospital surveillance, that needs to be informed to doctor as soon as possible. So this actually integrate, if we talk technically about this, ensemble deep learning with the edge computing, and actually automatically identify if there's a heart disease or not that. So first of all, that needs to be for an ensemble model needs to be trained with the data model. So that Clavel and UCI dataset is used by this paper, and that is first of all data model is trained so that whenever the new data is coming, that can be checked on that data set. Okay, this data is alarming or not. If according to that data model, ensemble data, deep learning data model, the data which is sent by this mobile app, in between there's a mobile app where an age for computing is sending that data to mobile app in real time, and that mobile app is actually doing the computation and sending that data to Fogbus broker and all that, and that actually communicate with the real time things. If there's a check with the data model, and if that data model is saying okay, the situation is alarming, that it inform to further. That's how this thing happened. Also all this needs to be happen really quickly and fastly. If this takes time, then obviously that is not useful. So here they are using Fogbus. Fogbus is already implemented a very good architecture, which is basically used for really fast fog and edge-based computing network thing. So they are major part of implementation is already implemented in a form of Fogbus, which they are directly using with the help of cloud labs and other infrastructure. Let's move forward. So here on the screen we are able to see the basic architecture. Like there are things, blood oxygen, heart rate, and all this data, blood pressure, all this data is transferred via the sensors and sensors to the mobile and the mobile app. Maybe via BLE data communication from the sensor, or that sensor nowadays. Let's suppose this a watch, iWatch related things. Then that can also transmit the data into Android phone app. And as soon as the phone app get the data that check against the data model which is already trained here in the Fogbus broker, which is part of this mobile app gateway device. So that will check with that help, which they are already data which is tested on the doctors and patient. That all is uh, that all is already given the results, and on those data trained data model we are actually check on that. If that is say okay, this is there's some alarming situation, then it will further inform to that thing. So there's a heart patient knowledge data knowledge base that will be regularly updated with the help of deep learning models. And here there's a focus worker. So that will continuously communicate with the results, and always learning with this continuously learning this deep model, and then it will inform to that data manager focus broker. And that way it will also use a cloud uh, uh, architecture with the help of Aneka. Aneka is again a software which is used in this software architecture in this paper. So that way it communicate continuously in real time, and due to that all this it will be automatically able to detect if there's any worst situation, critical situation of the patient, and that it further needs to be further communicate accordingly. Let's move further. That's how this data processing happened. So data commonly came from ECGs and other format, and we had to transform that graphical data formats into the quantitative or qualitative data formats, and that convert needs to be in a data sheet, a CSV, something like that, but mostly done by this Android app, and that communicates back to the data models in the form of that thing. And then we need to apply that data into assemble deep learning, which we already have the data from that UCI data set. Also, the real-time data we are getting, that also can be tested and trained again on the deep learning models. However, we're getting in the form of that way. Let's move to next thing. This is the app mobile app which is actually taking the master IP is configured again in the fog bus, and which is actually communicating in the real time all the data, and that all the other data is part of the all these segments are part of data set also. And also we can pass the data from the app to test that if it's safe or no need to worry, or there's a suggestion. This is just a graphical interface taken from the paper. And the next thing is about result, that is assemble average and best. So all the data training and testing result is shown. So basically this part is related to deep learning training part. So that is done on the Python, which I attach in the project. And this part is only this part is I'm able to achieve, not other the focus part. And that's from my side. Thank you so much.